And welcome to activity 25. Today we are going to talk about the law of sines. Now the law of sines can be kind of written as two different ways. So you have your side over the sine of the angle, and it's going to equal another side that is across from that angle's sine, or officially all three of these is essentially how that works. Or you could kind of have the reverse, where you write the sines all on the top and the cosine, or the sides all on the bottom. Officially, either you might see it represented either way, but when we solve, they end up giving us the same value, so it kind of doesn't matter which way you see that set up. Now, when are we going to use the law of sines? When you are given two angles and a side, or when you are given two sides and an angle, but a slightly different setup than our law of cosines, because we would use these in an oblique triangle that is giving us angle, side in the middle, angle, 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 and a side, or side, side, angle. Okay, so a little bit different than the side, 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 or side, angle, side that we saw with the law of cosines. Now that last one, side, side, angle, we are going to talk about that one a little bit more in later lessons about how that one can cause us potentially some issues. So in this first one, we are solving these by the law of sines. We want to find all of our missing angles and sides. Well, for the first part here, when we are looking for our missing angle over here, going back to what we've been talking about in our previous lessons, is that there are 180 degrees in a triangle. So if they're giving me 2 out of 3 angles, I'm just going to subtract from 180 to get my missing angle right here. So that first part, I didn't really even need law of sines or law of cosines to just find that angle. Now that angle is going to be very important though, because now that we have it, we have the side across from it is 12.9. And now that we have 55 degrees, we will plug that in for the sine. And then we are going to want to find our other two missing sides. So I'm going to start with the smaller side, which is going to be across from the smaller angle. So if I'm solving for B, that's going to be across from the 30-degree angle, so I'm going to use sine of 30. And then we're just going to cross multiply. 12.9 times the sine of 30 is going to equal B times the sine of 55, and then we want to get B by itself, so we're going to divide over that sine of 55, so that when we type this in the calculator, we end up with 12.9 times the sine of 30, and then all divided by the sine of 55. So again, we can type that in all as one thing, 12.9 times sine of 30. Make sure you close, not 3,000, make sure you close your parentheses and then divide that by the sine of 55. If you do not close your parentheses after that sine of 30, you will get the wrong answer. You should get 7.9 as the value for B. So B equals 7.9, and that'll be this side here. Now, our last side that we need is going to be set up similarly. I, again, like to use the 12.9 and the sine of 55 because I'm pretty confident in that angle is 55, just in case I type something in wrong. And then I need to find this other missing side. I'm going to call it C. It is across from the 95-degree angle. So again, what's going to happen is I need to multiply this time 12.9 times the sine of 95, and then that is going to get divided by sine of 55 because I would need to divide that over to get C by itself. So divide that then by the sine of 55, sine of 55, and we get about 15.7 for that missing side down here. Now, in our second example, we are being given the values here of our two sides and then an angle. So basically what we need to do to start on this one is we are given 7.2. We are given the side across, or the angle across from it is 62 degrees. The best we can do then, the other piece we are given is 4. We want to find the angle across from that. So this time we have to be very careful. We are going to multiply 4 times the sine of 62, and then that's going to equal 7.2 times the sine of x, and then we can divide that 7.2 over to get sine of x by itself. Now here's the thing, right? Sine of x equals this. That's not what x equals, that's what sine of x equals. So what we're going to do is when we type this in the calculator, we have, again, 4 times the sine of 62 degrees, divide that by 7.2, and notice it's this decimal number. That, again, is not the value of the angle. What we can do then is sine inverse that decimal value, and we are able to then actually get what the angle is. So you can either type it in as sine inverse, and then since we already typed that in, I like to hit second negative sign to plug that answer in. We get about 29.4 degrees as our answer there. You could also have typed that in inside here, the sine inverse. You could have actually just typed the 4 times sine of 62, close your parentheses, divided by 7.2, and still gotten that same answer. So you wouldn't have had to worry about the decimal or rounding. Now, our last two pieces then are our last missing angle, which is 180 minus the given angle minus that angle we just found. So we get 88.6 degrees. And then we also have, across from that, a missing side that we need to find. So again, I'm going to use the givens that we had from up above, the 7.2 over the sine of 62. I know that that's the side and the angle across from it. And then I need to find my last remaining side using the sine of the angle across from it, which we just found to be 88.6. So if we multiply 7.2 times the sine of 88.6, that will equal x times the sine of 62. Divide that sine of 62 over, though, to get x by itself. So if we type in 7.2 times the sine of 88.6, and then make sure we close that parenthesis, divide that by sine of 62, we get about 8.2 as our missing side down here. All right, there are two final ones then for you to try out on your own.